All right, so welcome back. We are continuing with the introduction to programming Python, the Princeton IntroCS course. So next we are doing lesson 1.2, built-in data types. So a data type is a set of values and a set of operations defined on those values. Many data types are built into Python language. In this section, we consider Python's built-in data types, int for integers, float for floating point numbers, str or string for sequence of characters and or text, and bool for true and false values. So here they give some examples. Let me try to zoom in here a little bit. Some table showing the built-in data types. So int, integers, and common operators to work with integers, common math operators you can see, sample literals, you have some numbers that you can work with. For integers, 99, 12, any large positive or negative number. Float, these are floating point numbers, operations you can use with them. And then also these are pretty much a number that is a decimal, positive or negative, like 3.14 or 2.5. Boolean or bool, these are true or false values, common operators with them and or not. And then you'll see true or false in Python. A string is a sequence of characters. It can be one character. An operator you can use with the plus symbol. And then some examples like AB, hello, 2.5. It can be long sentences, text or paragraphs as well. They can all fall under the string character. So I wanted to get my laser pointer here. There we go. So definitions. So to talk about data types, we need to introduce some terminology. To do so, we start with the following code fragment. So we have examples of storing values in a variable and a simple sum. So A is 1, 2, 3, 4, B is 99, C equals A plus B. This code creates 3 objects. Each type of int, these are ints because it's whole numbers, no decimals in it, using the literals 1, 2, 3, 4, 99, and the expression A plus B, and binds variables A and B and C to those objects using assignment statements. This is an assignment statement. We are assigning 1, 2, 3, 4 to the letter A, which will be a variable. Like X or Y, Z, this is what we are assigning 1, 2, 3 in memory in this variable called A, which we can use at a later stage. So the end result is that the variable C is bound to an object of type int, whose value is now 133. So again, this is maybe a bit technical language, but you can say that 1, 2, 3, 4 is now saved and stored in the letter A, which we can use later. So objects, all data values in Python program are represented by objects and relationships among objects. An object is an in-computer memory representation of a value from a particular data type. Each object is characterized by its identity, type, and value. The identity uniquely identifies an object, for example, int or float or string, and you should think of it as a location in computer's memory or memory address where the object is stored. The type of an object completely specifies its behavior, and a set of values it might represent, and a set of operations that can be performed on it. The value of an object is a data type value, and the value of an object is a data type value that it represents. So again, this is fairly technical. You don't actually have to know the details behind this, how it works, but typically this is just explaining the technical jargon relating to how this is stored. These are objects and how it's stored in memory and whatnot, but simply if you create a variable, A equals 1, 2, 3, 4, it's stored in memory and you can use it later. Like we're using it to create a simple sum, A plus B. Carrying on, each object stores one value. For example, an object of type int can store the value 1, 2, 3, 4, or the value 99, or the value 133, or whatever value you want. Different objects may store the same value. For example, one object of type string might store the value hello with quotes. This is a very important distinction. String needs to, the value needs to have quotes, either single or double. And another object of type string might store the same value hello. we can apply to an object any of the operations defined by its type and those operations. So the operations was defined here. For int, you can plus, add it, subtract it, multiply, float, the same bool, and or not, these are logical operators. And string, you can add string, like you're adding text, but we'll get to examples of that. So for example, we can multiply two int objects, but not two string objects. As you can see in this table, there's no multiply here. You can add two strings, you can add two words together, add two letters, that's fine, but you can't multiply them. Object references. An object reference is nothing more than a concrete representation of the object's identity, the memory address where the object is stored. Python programs use object references either to access the object's value or to manipulate the object reference themselves. Again, this is quite detailed, information regarding how this works behind the scenes. You don't have to know this to actually use Python, but I want to go through this because it's still useful to know. So literals, a literal is a Python code representation of a data type value. It creates an object with a specified value. For example, a literal was like, the number 1, 2, 3, 4 or 99. Operators, an operator is a Python code representation of a data operation. For example, Python uses plus to add and star to multiply. Python uses and or not to represent Boolean operations and so forth. And we'll get to more examples of that. Identifiers, an identifier is a Python code representation of a name. Each identifier is a sequence of letters, digits, and underscores, the first of which is not a digit. The following keywords are reserved and you can use them as identifiers. So these are various examples that you have. So now we're going we won't use much of them just yet, but it's useful to know what these are for the time being. So variables. So let's this picture's a bit small, so let me try and zoom in if I can. It's not helping. Hopefully you can see this. So variables, a variable is a name of an object reference, right? We spoke about object reference above here. Object reference is nothing more than a representation of the object. All right, so here we are actually using it now. So a variable is just the name of the object reference. We use variables to keep track of changing values as the computation unfolds. We use diagrams like the one on the right to show the binding of a variable to an object. So we have the variable A, which is the name of the object reference, and the object itself is 1, 2, 3, 4. So again, quite complex terms, or not complex, but I mean it's technical terms used to explain this very simple approach to how a variable stores value. We have a variable name, which is linked to which is a name of object reference, and the object itself is 1, 2, 3, 4. So and that is that number is a Python code representation of a data type of value. It creates an object with a specified value. So it creates an object, and this is the value 1, 2, 3, 4. So this is the object that it created, referencing to the literal. So again, quite technical, but it's useful to understand how things work in behind the scenes. So expressions, an expression is a combination of literals, variables, and operators that Python evaluates to produce an object. So you can think about everything as an object in Python. Each operand can be an expression, perhaps within parentheses. For example, we can compose expressions like 4 times brackets x minus 3 or 5 times x minus 6, and Python will understand what we mean. So here's an example of an expression where we have 4, which is multiplied by brackets x minus 3, and this is an expression that you might come across. Operators precedence. So an expression is a shorthand for a sequence of operations. Python's precedence rules specify the order in which the operators should be applied. For arithmetic operations, multiplication and division are performed before addition and subtraction. so that A minus B times C and A minus B times C represent the same sequence of operations. So this is also sometimes as a BODMAS is also sometimes used to kind of represent that this kind of operation. It's a math term to just explain the order of operations, operator precedence. I think it's called BODMAS. So again, so this represents the same sequence of operations. So when arithmetic operators have the same precedence, they are left associative, which means A minus B minus C and A minus B brackets minus C represent the same sequence of operations. You can use parentheses to override rules. So you can write A minus B, B minus C. If that is what you want. Full details, you can go to this appendix as well. So I think this should be straightforward. A basic arithmetic that you learn in school is applied in Python as well. Assignment statements. So an assignment statement is a directive to Python to bind the variable on the left side of the equal operator to the object produced by evaluating the expression on the right-hand side. For example, when we write C equals A plus B, we are expressing this action. Associate the variable C with the sum of the values associated with the variables A and B. Again, technical language describing what's happening behind the scenes. To use Python, you don't have to know into such detail. Informal trace. An effective way to keep track of the values associated with the variables is to use a table like the one at the right, with one line giving the values after each statement has been executed. Such a table is called a trace. Again, this is useful to understand how coding and how a computer program or computer language interprets expressions. So you are more than welcome to go through this table and how it works. But again, for practical cases, we're not going to go into too much detail with traced tables. Object level trace. So for example, for complete understanding, we sometimes keep track of objects and references in traces. The object level trace at the right illustrates the full effect of 3 assignment statements. So the statement A equals 1, 2, 3, 4 creates an int object whose value is 1, 2, 3, 4. It is then binds the variable A to this new int object. So A equals 1, 2, 3. This is this little diagram, the variable A, object reference to the object 1, 2, 3, 4. The statement B equals 99 creates an int object whose value is 99. It then binds to the variable B to this new int object. The statement C equals A plus B creates the int object whose value is 133 as the sum of the value of the int object bound to A and the value of the int object to B. If it binds to the variable C to the new, it then binds the variable to C in the new int object. So again, very technical, describing this very simple process. We just store 2 numbers in 2 variables and add them. Python makes it again very easy for you to perform this. This is very highly technical. You don't have to understand how this language specifically, creating an int object and binds a variable to B. To use Python, you don't need to know this. It's just useful to understand, though, how things happen behind the scenes. So strings. The string data type represents strings for use in text processing. So this little diagram shows it's a sequence of characters. Typical, can be like hello world or Python. Python with /s. We can also do concatenation or add words together. And the only operator you can use is a plus to add words. So the value of a string object is a sequence of